Hi everyone, what's up? In our last class, we have learned about Rawls' law, Dalton's law, the positive deviation, the negative deviation. Hope all of you are clear with all those topics. Hope you have untested all those topics. Have you learned it actually? I've already told that you have to learn the topics which I'm taking all the days. Okay, for the next class. Okay, before starting my this session, I just wanted to know whether you have learned the previous topics which I've taken in my part 3, right? Part 3. Yeah, this is going to be part 4 of solutions of chapter 12, the first chapter, and this is going to be the last part of solutions. So in this part, we are going to learn about SU-tropes, the colligative properties, and few problems related to this chapter, 8 to 10 problems. So by that time, okay, we need to brush up the things which I've learned in our last class. We have learned about Rawls' law, Dalton's law. What was Dalton's law saying? What was he saying in that law? What was Dalton saying about the partial pressure, the uh, pressure of individual component? What was he saying actually? He was saying that if you take a solution, the vapor pressure of that solution or the total vapor pressure of a solution will be the sum of the partial pressure or vapor pressure of individual components. Clear? He explained that the total vapor pressure of a solution is the sum of the vapor pressure of individual components. That is PT or PS will be the sum of PA plus PB. Okay, the sum of PA and PB. And what was saying in the Rawls law? In Rawls law, it was said that if you consider a solution, the partial pressure of each component will be directly proportional to the mole fraction. Pa directly proportional to chi A, Pb directly proportional to chi B. And if you remove the proportionality and by introducing proportionality constant, we'll get Pa equal to P naught A chi A, Pb equal to P naught B chi B. Then we have learned about the ideal solution. Ideal solution are solutions are those solutions which show or which obey Rawls' law, okay, which obey Rawls' law, okay, in all range of concentration. And non-ideal solutions are those solutions which do not obey Rawls' law, and they show deviation from Rawls' law either by positive deviation or by negative deviation. What is positive deviation saying about? Pa will be greater than P naught A chi A. Pb will be greater than P naught B chi B in positive deviation. In the case of positive deviation, the interaction between AA, solid particles, interaction between solvent particles, okay, solid particles BB and the interaction between solute particles will be greater than the interaction between solute and solvent. And the enthalpy of mixing, the volume of mixing will be greater than 0. In the case of negative deviation, we'll be having a vice versa case in negative deviation to that of positive deviation. That is, Pa will be less than P naught A chi A, Pb will be less than P naught B chi B, and the enthalpy of mixing or the volume of mixing will be less than 0. Okay, and even the AA interaction, BB interaction will be less than AB interaction, the solid-solvent interaction. Hope all these topics are clear. Fine. And what are the characteristics of ideal solution? Enthalpy of mixing and volume of mixing is 0. Also, Pa equal to P naught A chi A, Pb equal to P naught B chi B. The AA interaction, BB interaction will be equal to AB interaction. All these characteristics are for ideal solutions. So, by knowing all these, we are coming to a new topic today, that is azeotropes. What are azeotropes? Just keep this topic in mind as just a topic. Okay, you don't have to go in detail about azeotropes. You don't have to dig in the topic. Azeotropes means consider a container. In this container, I'm mixing two components, A and B. These A and B, okay, A and B, they boil at constant temperature. Means what? They have a constant boiling point. They'll have constant composition in vapor phase and also in liquid phase. When I heat the mixture, okay, the mixture is having A and B, right? They'll boil at constant temperature. What happens after boiling? The composition of A will be the same in liquid phase and in vapor phase. The composition of B will be same in liquid phase and in vapor phase. As the boiling point is constant for A and B, We can't separate these components A and B by fractional distillation. So that are the properties of, those are the properties of azeotrops. So see, azeotrops are binary mixture. Binary mixture. What is binary mixture? In the previous session, I think in the part 1 of solutions, I've told you what is a binary solution. Binary solution means a solution having two components. Binary mixture means a mixture having two components. So azeotrope is a binary mixture. It has two components only. That is A and B. Consider it as A and B, and having same composition in liquid and vapor phase. After boiling, it will have same composition. If 30% of A is present in the liquid phase of a solution, 30% of A is present in the vapor phase also after boiling. Okay, so they have same composition in liquid and vapor phase, and also they boil at same temperature. They have constant boiling point. There are two types of azeotropes. That is minimum boiling azeotrope and maximum boiling azeotrope. Minimum boiling azeotrope means we already know what Rawls law is. So we also know that positive deviation and negative deviation from Rawls law can occur. So those substances which show positive deviation, large positive deviation from Rawls law, are called minimum boiling azeotropes. Minimum boiling azeotropes are those components. See, the solutions which show large positive deviation from Rawls law is called minimum boiling azeotrope. So what is maximum boiling azeotrope? Yeah, the vice versa case. Those who show negative deviation from Rawls law, large negative deviation from Rawls law, and they are called maximum boiling azeotropes. So in the case of azeotropes, or the topic of azeotropes, you just have to know what azeotrope is and what are their properties. Also the divisions of azeotrope, that is into minimum boiling azeotrope and maximum boiling azeotrope. Now we are coming into the last topic of this session, or not only the session, the last topic of chapter 1 of plus 2 chemistry, solutions. Last topic of plus 2 chemistry, first chapter, solutions, is that colligative property. Is the colligative property. What is colligative property? If you ask me what are my properties, I'll say I'm a student, I'm a teacher, I love dancing, I love this, that. Yeah. All these are my properties. Okay, and I'm asking a liquid or a solution. I've met a solution, and I'm asking the solution, what are your properties? Okay, and the solution says, I have colligative property. Okay, what is colligative property then? Colligative property is a property of solution. Obviously, it's a property of colligative solution. Colligative property is a property of solution. So on what basis colligative properties change? Colligative properties change only on the basis of number of solute particles. So consider you're going or you're seeing a showroom, a branded clothing showroom, while passing through a road. Okay, so you saw that showroom, and you're not going to enter that showroom anyway at any cost. But at your first glance, you have seen many people entering, many people leaving, a large number of people inside the showroom. So you'll think that, okay, this is a nice showroom, I guess. But you're not evaluating the quality of showroom on the basis of the quality of the materials they provide, on the range of prices they sell, their properties. So just evaluating the showroom on the base of number of people entering the showroom or number of people getting out of the showroom, right? Or the number of people present in the showroom. So same way, in the case of colligative property, it depends only on the number of solute particles present in a solution. Okay, it's a property that changes on the basis of a ratio of number of solute particles to number of solvent particles in a solution. Fine. So what are the colligative properties that a solution has? So what are the colligative properties that a solution possess? They are relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmosis. Those are the 4 colligative properties of solution. So let's look into those in detail. Before that, just keep in mind that these colligative properties are used to find the molar mass of solute. W2. The molar mass of solute is found by using these four colligative properties. So I have already said that these four colligative properties depend upon the number of solute particles. So definitely we can use these four colligative properties to find the molar mass of solute in a solvent. That is, not W2, it is M2. M2. So in these four colligative properties, you have to learn the title of these colligative properties, like which are the colligative properties. The question will be asked like which are the colligative properties that the solution has. So a solution have, the solution possess. So you need to name it, like elevation of boiling point, depression of freezing point, osmosis, relative lowering of vapor pressure. These are the four colligative properties of a solution. Next, you need to know the derivation part of each colligative property. The question may be asked like this: derive the equation for molar mass of a solute using relative lowering of vapor pressure, or depression of freezing point, or elevation of boiling point. In each colligative property, you'll have a derivation to find the molar mass of solute. So let's look into it in detail. The relative lowering of vapor pressure. Consider two containers. In the first container, I'm having a pure component of A. Let the partial pressure be P naught A. In the second container, I'm having A itself, but a mixture of A with some other substances. So the vapor pressure will be PA. Vapor pressure will be PA. So is the P naught A higher or PA higher? Let the container 1 have water. I'm boiling it, and as we all know, it's a volatile liquid. It will vaporize, it will form vapors, it has vapor pressure. I'm adding some substance to it, namely salt or sugar. So the vapor pressure decreases or increases after adding, after forming solution. Vapor pressure decreases, right? So P naught A is greater than PA. P naught A is greater than PA. Therefore, the change in vapor pressure equal to delta P equal to P naught A minus PA. Is that clear? P naught A minus PA, because P naught A is greater than PA. Now, the equation, a direct equation, I'm putting a direct equation to this case, that is delta P by P naught A. Delta P by P naught A. We need this equation to find the molar mass of solute. This delta P by P naught A can be substituted with the above equation, P naught A minus PA divided by P naught A. This is directly, which is equal to the mole fraction of solute. Okay, the ratio of change in vapor pressure to the pressure of pure component of a substance is equal to that mole fraction, right? Mole fraction. Where have we come this? We got this equation from PA equal to P naught A chi A. We know this equation. So from this equation, we got this equation. Is it clear? So delta P by P naught A equal to P naught A minus PA by P naught A. That is equal to mole fraction of solute. Now, mole fraction of solute. So how, mole fraction of solute. What is mole fraction of solute? Chi 2. How are we going to find chi 2? Chi 2 equal to N2 by N1 plus N2. N2 by N1 plus N2. Consider the solution is very dilute. Very dilute means the number of solute particles is few, very few in a solvent. So it's a dilute solution having very few solute particles. So excluding the solute particles, that is N2 here, I'm going to exclude this. So the equation is simplified to N2 by N1, right? So substitute this here. On substituting, we'll get chi 2 equal to N2 by N1. Now, N2 by N1 means what? W2 by M2 whole divided by W1 by M1. I just rearrange it by putting the denominator into numerator, M1 by W1. Hope this is clear. So substitute this here, N2 by N1, in the position of N2 by N1. So what do we get? What do we get? We get, we get this equation. P naught 1 minus P1 divided by P1 naught equal to W2 into M1 by M1 W1 into M2. From this we can find M2. M2 equal to P1 naught, M2 equal to W2 into M1 into P1 naught divided by P1 naught minus P1 into W1. Hope this is clear. Taking M2 to numerator, we'll get P1 naught to the numerator, P1 naught into W2 into M1 divided by P1 naught minus P1 into W1. This is equation to find molar mass in the case of relative lowering of vapor pressure. Hope the derivation is clear. Now we are having a problem here. The vapor, this is a problem from NCERT. Okay, very direct question. The vapor pressure of pure benzene at a certain temperature is 0.850 bar. Vapor pressure of pure benzene, C. Pure benzene means what? P naught A equal to 0.850. Bar is a unit of expressing pressure. A non-volatile, non-electrolyte solid weighing 0.5 gram. W2 equal to 0.5 added to 39 gram of benzene. 39 W1 equal to 39 gram of benzene. Molar mass of benzene is given, that is M1 equal to 78. Vapor pressure of solution then is 0.845 bar. Vapor pressure PA equal to 0.845. I've already told you that when a solution is made, the vapor pressure lowers than the pure component. What is the molar mass of the solid substance? So for the equation we need to know this quantity also. P1 naught minus P1, that is a change in vapor pressure. So change in vapor pressure, delta P equal to P1 naught minus P1, that is equal to, or PA naught minus PA, 0.85 minus 0.845. Just calculate it and find the answer. Find delta P equal to P1 naught minus P1. So substitute these values in the equation provided here to find the molar mass of the solute using relative lowering of vapor pressure technique, colligative property. Is that clear? Now we are moving on to elevation of boiling point. Elevation of boiling point means consider two containers. As we discussed the case earlier, I'm taking a component here. It is a pure component. So we are saying about the elevation of boiling point, right? So boiling point here it is T naught B. I'm mixing this A with some other solution, some other components, say B, whatever. The boiling point changes to TB. So tell me T naught B or TB is higher. When I'm taking pure component water, it is easy to boil, right? So the T naught B is less. When I mix it with some other component, the boiling point is very high. What is boiling point? The temperature at which a substance can be boiled. So TB is higher here. TB is higher here. TB. So coming to the delta TB equation, here it is already written. Delta TB, change in boiling point is delta TB equal to TB minus T naught B. TB minus T naught B. So we know that delta TB is directly proportional to molality. Then, removing the proportionality, we introduce a constant Kb into molality. Kb into M. Kb means molar elevation constant. Now, Kb into what is molality, number of moles of solute divided by mass of solvent in kilograms, right? So, number of moles of solute means W2 divided by M2 into W1 into 1000. That is equal to delta TB, right? Delta TB. From this equation, we can reach the equation of molar mass of solute using elevation of boiling point. This is the equation. Using this equation, shall we do a problem from NCERT textbook? Very simple derivation. You can do it in 3 to 4 steps itself. Boiling point of benzene is 353.23 Kelvin. Let's substitute here. Boiling point of a benzene, right? T naught B equal to 353.23 Kelvin. 23. When 1.80 gram of a non-volatile solute, W2 1.80, is dissolved in 90 gram of benzene, W1 90. The boiling point is raised to 354.11, right? Calculate the molar mass of solute. Kb is given 2.53. Kb equal to 2.53. I've already said when a pure substance is boiled, it is easier to boil than a mixture of two components. Means the boiling point will be higher for a mixture than a pure substance. That's why we can see here the T naught B is less than Tb. T naught B is less than Tb. So how do we find delta Tb? Delta Tb for the equation provided here. It is 354.11 minus 353.23. Just do the calculation and find delta Tb and substitute the value of that in the particular equation of M2, molar mass of solute. We have got this equation through which colligator property method? Elevation of boiling point. Now coming to depression of freezing point. As we done earlier, take two containers. I'm having a component here and the freezing point of the first substance in first container is T naught F. I'm having a mixture of A and some other component in the second container. And the freezing point is TF. So which will be higher? Which is easier to freeze? TF is higher or T naught F is higher? Yes, obviously T naught F is higher. T naught F is higher than TF. Okay, so from that relation we got delta TF equal to T naught F minus TF. We already know that delta TB equal to KB into M, where the change in boiling point of two substances is equal to the molality and Kb. Kb is the molar elevation constant. As same as this, we have delta TF. Delta TF, freezing point, changing freezing point equal to Kf into M. Constant form freezing point is Kf into M. M means molality. Substitute the equation for molality and you will get M2 equal to Kf into W2 into 1000 divided by delta TF into W1. What's the only change that you can see in the case of elevation of boiling point and depression of freezing point in the equation of molar mass of solute? The only difference in the equations of finding molar mass from the derivation of elevation of boiling point and depression of freezing point is that the Kf in boiling point case is substituted by Kb and delta Tf in this case is substituted by delta Tb in the case of elevation of boiling point. That's the only difference. So shall we do a problem from the freezing point section? If you're ready, I'm also ready. Shall we do? So the question is freezing point, right? Let me check. The question is not provided in the PDF, so I just have to go through the question. Not go through. Actually, I have to find out the question from my phone. Anyways, I'll find it very soon. Yeah, we got it. We got it. So, just know the question. I am going to read it out. The question is already there in the NCERT textbook. So, if you have NCERT textbook in your hands or PDF, please read the question. 1 gram of known electrolyte solute. 1 gram. Okay? 1 gram. W2 equal to 1 gram. Dissolved in 50 gram of benzene. W1 equal to 50 grams. Lower the freezing point of benzene by 0.40 Kelvin. Lowered the freezing point. Lowered the freezing point means what? Delta TF. delta TF equal to 0.40 Kelvin. The freezing point depression constant of benzene T sorry constant, right? Constant for freezing point Kf equal to 5.12. 5.12. Hence find the molar mass. Hence find the molar mass of solute. So how do we find the molar mass of the solute? From these details given. It's easy, just substitute in this, right? Delta TF is given. We need delta TF, it is given. W1 is given. Kf is given. W2 is given. Just find the molar mass of solute from these details. We have one more topic to be taken here. I have not given this in the PDF. That is osmosis and osmotic pressure. That's the last colligative property we have to discuss, right? So just note the title, osmosis. Osmosis. Shall we change the color? Okay, osmosis. What is osmosis? You've heard about osmosis, the term osmosis, or the process of osmosis. You might have come across the process of osmosis in your previous classes, maybe in plus one biology. In biology, I think in botany, right? Botany, you have to learn about osmosis. Okay, so I'll just explain what osmosis is. Consider a container here. I'm separating the container using a semi-permeable membrane. Semi-permeable membrane means a membrane which allows some particles, selective particles, to go through it. Okay, it's actually working as a gate. Gate means it will stop some people from entering home, right, or a building premises. So gate, what a gate, the function of a gate. What is the function of a gate? It stops some people from entering the particular area, right? It allows some people to enter to the particular area, right? So the same way, the semi-permeable membrane used here allows some particles to go through it, but it blocks some other particles. Such a membrane is called semi-permeable membrane. Here, consider a solution. Here also we have a solution. The thing is that the solution in both sides have same quantity of solvent. What differs is the solute particles, number of solute particles. Here we have 3 solute particles. Here I have more number of solute particles. 2, 3, 4, 5, 6, 7, 8. Okay. So osmosis is a process by which solvent passes from the region of low solute concentration to the region of high solute concentration. Means here the solute particles in the left side, the solute particles is very few. So the solvent, what will the solvent do? It will go from here to here, to the region of having high solute concentration. So solvent will move from the region of low solute concentration to the region of high solute concentration. Such a movement, such a process is called osmosis. How can we stop osmosis? Just apply a pressure to the high concentration area. Just apply a pressure here, and that pressure is called osmotic pressure. Osmotic pressure is a pressure by which we can regulate osmosis, we can control osmosis, or we can block osmosis. It is applied to the region of high solute concentration. Clear? Now, how can we find the equation of molar mass of solute from osmosis? Osmosis, it is depicted by pi. It is equal to CRT. T means temperature, R means universal gas constant, and C can be replaced by capital M. Molarity. Molarity means what? Number of moles of solute by volume of solution, right? Number of moles of solute, W2 by M2 into V RT. This is the equation to find molar mass. M2 means, just rearrange it. We'll get W2 RT divided by pi V. This is the equation to find the molar mass of a solute by using osmotic method, osmosis. Hope it's clear. And now we are going to the problem section of this particular chapter. We have completed all the topics from solutions, and now we are moving on to the questions. Previous year questions are questions from NCRT. Note down the first question. It is number of moles of solute per kilogram of solvent is called. Molarity or molality. We have molality small m, molarity capital M. Molarity means number of moles of solute, number of moles of solute divided by mass of solvent or volume. Molarity capital M. It is volume of solution. And what about the small m? Number of moles of solute by mass in kilograms. Among the following, which is not a colligative property? We have osmotic pressure here, elevation of boiling point, vapor pressure, and depression of freezing point. You have learned all the 4 colligative properties, right? So which is not a colligative property here? It is obviously vapor pressure. It is not a colligative property. Second question, name the 4 important colligative properties. Which are the 4 important colligative properties? Elevation of boiling point, depression of freezing point, osmosis and osmotic pressure, also relative lowering of vapor pressure. Calculate the temperature at which a solution containing 54 gram of glucose in 250 gram of water will freeze. Kf is given here, so we need to use the equation of elevation of boiling point and depression of freezing point. We need to use that equation of depression of freezing point because Kf is given, not Kb. So what is the equation? We need to find, according to the depression of freezing point, we need to find the the temperature. We need to find the temperature, delta Tf. Delta Tf means what? Kf into W2 into 1000 divided by W1 into M1, right? W1 into M2. So here, according to this equation, we are finding delta Tf, that is the temperature, delta Tf. So, at which a solution containing 54 gram. 54 gram means what? W2 equal to 54. W1 equal to 250 gram of water, right? Kf is also given. Kf equal to 1.86. So, W2 is given, W1 is given, Kf is given. We need to find M2, right? Molar mass of what? Glucose. The molar mass of glucose is C6H12O6. 6 into 12 plus 12 into 1 plus 16 into 6. You will get 180 grams. So substitute this 180 gram in the case of M2. We already have W2, W1, Kf, etc. And the final answer that you will be getting is delta Tf equal to 2.23 Kelvin. But that's just delta Tf, right? Delta Tf. What you have to do is T0 F minus Tf. That is 273 Kelvin minus 2.23 Kelvin must be done. And the answer will be 270.76 Kelvin. Because the question is asked about the temperature at which solution will freeze. It is asking the TF value or it is asking about the temperature of solution. Fine. Elevation of boiling point is directly proportional to molality, right? From the above relationship, derive an expression for expression to obtain molar mass. I'm just briefing the derivation. For detailed derivation, go back. Okay. Delta TB equal to Kb into M, where delta TB is a change in boiling points, Kb is the molar elevation constant, and the small m is molality. Okay, so this can be done by Kb equal to Kb into molality, the equation of molality, given mass W2 by M2, W1 into 1000, mass of solvent in kilograms. So before that, you need to derive the equation for delta TB by considering case of two containers. Then show delta TB is directly proportional to molality, and also introduce the proportionality constant. Now the next question is, the boiling point of benzene is 353.23 Kelvin. Okay, so as per this, okay, boiling point of benzene, that is T naught B, equal to 353.23 Kelvin. When 1.80 of a non-volatile is added, was dissolved, that is W2 equal to 1.80. In 90 grams of benzene, W1 equal to 90. Boiling point is raised, TB equal to 354.11. Calculate the molar mass of solute. We need to find this. We are provided with T naught B and TB. From this, we can find delta TB, that is 354 minus 353. W2 is given, KB is given, KB isn't given. KB, calculate the molar mass of the solute, right? So, KB for the equation, the boiling point of benzene is 353 point, T naught B is given. So I've missed the part of KB in the question. So just note the question, KB equal to 2.53, okay? KB equal to 2.53. The KB value is a constant value and it will be given in the question itself. So I was checking for KB. Okay, where's KB? KB. And finally I found KB isn't given in the question, and that's my mistake. So KB will be given in the question. Don't worries. Okay, so just substitute all these values and you'll get the molar mass of solute. Name the law which helps us to determine partial vapor pressure of a volatile component. Which was the law? Which is the law? Rawls law. Yeah. State the law. We already know what the law says. Just keep the concept in mind, and you need to just put those ideas into words. Okay, you need to transform those ideas into words. You know what Rawls law says, right? If a solution is taken and the components, individual components, the partial pressure of individual components will be directly proportional to the mole fraction of that component in that solution. That is the concept that the law provides, right? So just put those into words. Vapor pressure, okay, vapor pressure of chloroform and dichloromethane is given 200 and 415. Calculate the vapor pressure of solution prepared by mixing 24 grams of chloroform and 17 grams of dichloromethane at 298 Kelvin temperature. You need to find the vapor pressure of solution. You know the vapor pressure of solution, or the equation for vapor pressure of solution, that is P equal to P1 naught plus P2 naught minus P1 naught into Chi2. This equation is derived from what? Or from where? From Rawls law. So here P1 naught is given, that is 200 mm. P2 naught is given 415 mm. You just have to find Chi2. Chi2 means what? Chi2 is N2 by N1 plus N2. N2 by N1 plus N2. For N2, you need to do W2 by M2. W2 by M2 means 24 divided by the mass of chloroform. The mass of chloroform is 78. Chloroform means CH, chloroform, fine, CHCl3, right? You're provided with the masses of CH and Cl. So from that you need to find the mass of chloroform, 24 by 78. Also 17 grams of dichloromethane. How do we find the mole fraction? N2. For N2, not W2 by M2. For Chi2, we need to find N1 and N2, right? So for that, you also need to find the number of moles of dichloromethane present here, and that is 17 grams divided by the mass of dichloromethane is, 1 second now, I think I've gone wrong somewhere. Okay, sorry. In the previous case, it was 24 grams, right? 24 grams. I'll just explain it once more. You need to find Chi2, right? Chi2 means N2 by N1 plus N2. So for this, we need to find N2. So N2 means number of moles of the solute. Given mass 24. divided by mass of CHCl3. CHCl3, it is N2 is 119.5. The number of moles is zero point 0.2. Similarly, for N1, it is given mass is 17 divided by 85. Dichloromethane, right? Okay, for dichloromethane, it is 17 divided by 85. Yeah, CH2Cl2, dichloromethane. Number of moles is 0.2. So what do you have to do? 0.2 and 0.2, right? So substitute these in the equation of chi2. You'll get chi2 equal to 0.2 divided by 0.2 plus 0.2. Find the answer for this and substitute in the equation for P. The fifth question is calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. So for that, you need to find mass percentage, right? Mass percentage means what? The mass of a particular component to the total mass of the solution, right? So mass percentage of benzene means mass percentage of benzene equal to, given mass is 22. We need to find total mass of the mixture. Total mass of the mixture means 22 plus 122. How do I get 22? 22 is given here, 122 is given here. That is a mass of benzene, carbon tetrachloride, sum it, and you will get 144. That is the total mass of the mixture. So to find mass percentage of a particular component, just divide the particular mass given in this question of that component to the total mass of the solution or the mixture, that is 144, and multiply it with 100%. Similarly, mass percentage of carbon tetrachloride CCl4 equal to, given mass is 122, total mass is 144 into 100%. The answers are given here: 15.28%, 84.72%. Sixth question, for determining molecular mass of polymers, osmotic pressure is preferred to other properties. Why osmotic pressure is preferred? There are two reasons for that. First of all, in osmotic pressure, we measure the pressure in room temperature. We measure the pressure in room temperature for the case of osmotic pressure. The second reason is that instead of molality is used. Molarity, capital M. Capital M is used instead of molality, small m. Okay. These are the answers for first question. For intravenous injections, only solutions with osmotic pressure point depression equal to that of 0.9% of NaCl is preferred. Why? The reason is that while you are injecting something to your body, osmosis shouldn't take place. You know what osmosis is, right? The movement of solvent particles from a area of less or lower solid concentration to that of higher solid concentration. So such a concentration difference shouldn't happen while we are taking injections. Means osmosis shouldn't take place. So for this, while injecting something to our body, the substance should contain same concentration as that of our body fluids. So 0.9% of NaCl is preferred because 0.9% of NaCl has same composition or same concentration as that of our body fluids. Okay, same concentration of our water in our body, same concentration of solutes in our body. So it is having all those properties who is having NaCl is having. It is an isotonic solution. Isotonic solution means those solutions having same concentration as that of our body, as that of body fluids. So 0.9% of NaCl is preferred. The seventh question is, what are azeotropes? We have discussed what are azeotropes, all the properties. So azeotropes are binary mixtures having same constant boiling pressure. Boiling point, having constant boiling point, and they have same composition in the vapor phase and also in the liquid phase. Also define the minimum boiling azeotropes. Molarity, molality, and mole fraction, etc. are some methods of expressing concentration of solutions, which among those is temperature independent. is temperature independent. Of course, mole fraction is temperature independent, we know that. But coming to molarity and molality, we have discussed this in previous classes. This is molality, okay? Molality. In the case of molarity, capital M, we have number of moles of solute divided by volume of solution letters, right? In the case of molality, small m, we have number of moles of solute by mass of solvent in kilograms. So which is temperature dependent? Volume is temperature dependent or mass is temperature dependent? Obviously, volume is temperature independent. So molality is also temperature independent mole fraction also. Molarity is temperature dependent because volume changes with temperature. It is temperature dependent. Okay. What are ideal solutions? What are ideal solutions? Give their properties. You know what is an ideal solution, right? Those solutions which obey Rolle's law over a range of concentration. Pa equal to P naught A chi A, Pb equal to P naught B chi B, and also A interaction, Bb interaction will be equal to AB interaction. All those properties are shown by ideal solutions, and the enthalpy of mixing, volume of mixing will be equal to 0. Calculate the mole fraction of benzene in solution containing 30% by mass in CCl4. So mole fraction of benzene is chi2. Chi2 equal to N2 by N1 plus N2. N2 means benzene. It is having 30 grams, given mass is 30, and find out the mass of benzene C6H6 and substitute here M2. You'll get N2. For N1, we have 70 grams, like 70 grams, because 30% of the solution is benzene. So the remaining 70% will be CCl4. It is a solution of CCl4. It's a solution of benzene in CCl4. Okay, so 70% of CCl4 divided by M1. You'll get N2, N1, substitute in chi2. The answer will be 0.458. 0.458. This will be the answer. All right. Hope you enjoyed this session, and in the coming sessions we'll be discussing another chapter of +2 chemistry. So by that time, just learn all the problems, do practice the problems which I've taken in these sessions. I've worked out around 15 to 20 problems in these four parts of solutions of class 12. So just go through all the problems, all the topics I've taken. Just confine yourselves to the lessons which I'm teaching you here. It's all that essential, all that is required for your level of education, that is +2 level. So we'll meet in another session. Till then, bye.